Good morning. Now we will discuss the summary of Chapter 7 entitled IP Addressing. Addressing is a critical function of network layer protocols. Addressing enables data communication between hosts regardless of whether the hosts are on the same network or on different networks. Both Internet Protocol IP version 4 or IPv4 and Internet Protocol version 6 or IPv6 provide hierarchical addressing for packets that carry data. Designing, implementing, and managing an effective IP addressing plan ensures that network can operate effectively and efficiently. This chapter examines in detail the structure of IP addresses and their application to the construction of and testing of IP networks and subnetworks. Positional notation. Learning to convert binary to decimal requires an understanding of positional notation. Positional notation means that a digit represents different values depending on the position the digits occupies in the sequence of numbers. You already know the most common numbering system, the decimal or base 10 notation system. The decimal positional notation system operates for the description of each row. So, decimal to binary conversion. It is also necessary to understand how to convert a dotted decimal IPv4 address to binary. A useful tool is the binary positional value table. Network and host portions. Understanding binary notation is important when determining if two hosts are in the same network. Recall that an IPv4 address is a hierarchical address that is made up of a network portion and a host portion. When determining the network portion versus the host portion, it is necessary to look at the 32-bit stream. Within the 32-bit stream, a portion of the bits identify the network, and a portion of the bits identify the host as the bits within the network portion of the address must be identical for all devices that reside in the same network. The bits within the host portion of the address must be unique to identify a specific host within a network. If two hosts have the same bit pattern in the specified network portion of the 32-bit stream, those two hosts will reside in the same network. But how do hosts know which portion of the 32 bits identifies the network and which identifies the host? That is the job of the subnet mask. Chapter 7, IP addressing. IP addresses are hierarchical with network, subnetwork, and host portions. An IP address can represent a complete network, a specific host, or the broadcast address of the network. Understanding binary notation is important when determining if two hosts are in the same network. The bits within the network portion of the IP address must be identical for all devices that reside in the same network. The subnet mask or prefix is used to determine the network portion of an IP address. IP addresses can be assigned either statically or dynamically. DHCP enables the automatic assignment of addressing information such as IP address, subnet mask, default gateway, and other configuration information. IPv4 hosts can communicate one of three different ways: unicast, broadcast, and multicast. Also, Blocks of addresses that are used in networks that require limited or no internet access are called private addresses. The private IPv4 address blocks are 10.0.0.0/8 or 172.16.0.0/12 and 192.168.0.0 or 16 or /16. The depletion of IPv4 address space is the motivating factor for moving in IPv6. Each IPv6 address has 1 to 8 bits versus the 32 bits in an IPv4 address. IPv6 does not use the dotted decimal subnet mask notation. The prefix length is used to indicate the network portion of an IPv6 address using the following format: IPv6 address or prefix length. There are three types of IPv6 addresses: unicast, multicast, and anycast. An IPv6 link local address enables a device to communicate with other IPv6 enabled device on the same link and only on that link or the subnet. Packets with source or destination link local address cannot be routed beyond the link from which the packet originated. IPv6 link local addresses are the FE80/10 range. ICMP is available for both IPv4 and IPv6. ICMP v4 is the messaging protocol for IPv4. ICMP v6 provides the same service for IPv6 but includes additional functionality. After it is implemented, an IP network needs to be tested and verify its connectivity and operational performance. So that's all for the summary of Chapter 7, and see you on the next video for the summary of Chapter 8. Thank you for watching and I hope you learn more.